All right, so the question was, if you're flipping a coin 4 times, what are the odds that I think the question was, what are the odds that you get a head every time? So let's pretend we don't know the answer. We're going to figure it out, the same idea, but we're only going to flip the coin twice, right? And this is what they call a sample space. This is a set that describes all the possible outcomes for flipping a coin twice, right? So you could get a heads the first time and a heads the second time. That's actually what we're trying to do. Or you could get a heads the first time you flip it and a tails the second. Or tails and then heads, or then tails and then tails. Now, you probably don't want to list something like this out for, for the 4 coins, but you could, right? It would just take a little while. See, for this one, there was only 4 possible outcomes, all right, because there were, in flipping a coin, there's only 2 possible ways that could fall, and you were repeating the activity twice. You were only flipping it twice. So the multiplication rule is, 2 times 2, and so that gives you a sample space of 4 possible outcomes. So the chances of that happening for heads, which is what we were trying to do, is 1/4. But the same question could be asked for much larger ones. Let's say you're flipping the coin 30 times and you want to figure it out, right? Obviously there's a pattern here. You could probably figure it out like that, but there's a better way to answer questions like this, right? And it has to do with this multiplication rule for independent events. And independent events just means that the probabilities are completely unrelated. Like when you flip the coin that first time, it has no actual impact for when you flip it the second time. All right. But an example of a dependent event would be something like, let's say there's a bag of marbles here, some are green and then some are red, right? Well, if we want to ask the question, what are the chances that you get 2 green marbles in a row, assuming that you do not replace the green marble that you get the first time. That would be an example of a dependent event, because what you get on the first instance affects the probability for the second instance. But we're not touching those right now, so forget those. We have independent events because, flipping the coin twice, no matter how many times you flip the coin, the previous results do not impact that. All right. So the multiplication rule for independent events is right here. It says if you want the probability of something to happen and something else to happen, what you can do is multiply the probabilities. P of A times P of B. So what I'm going to do is I'm going to rewrite this question, the one for flipping 2 coins, is I'm going to say, what's the probability that we get a heads the first time? There we go. A heads the first time and a heads the second time. So probability of heads and heads. Well, that multiplication rule says I can rewrite it as probability of heads times the probability of heads. Right? And these are easy questions to ask because you've broken it down into single events. Well, what are the chances of getting a heads the first time? It's 1/2. And what are the chances of getting a heads the second time? It's the same thing. But when you multiply those probabilities, you'll get 1/4, and that matches our answer for the sample space up here. So this is a much more efficient way for answering certain probability questions. Okay, you should be good now.